The calculation that you made for the areas that you were studying in California, how did they stack up looking at a European city? Have you done that?
You know, that's actually a good question for Gary. He might know the answer to that. I don't know. I know that the Europeans are very interested in this and would like to actually develop some models of their own. And I think that the model that the Pacific Institute came up with could be adapted for use for evaluating European embedded energy use. But I suspect, depending upon the treatment levels and how far the water is being pumped, it should be comparable. Gary, Gary, do you have any illuminating thoughts on this?
Thank you. Fundamentally, the average U.S. water supply is pumped from a certain depth. Think Kansas. You've got to deliver it up from a well. Most communities don't have gravity-fed water, and most communities don't have significant amount of transported water like we do in California. So the water supply in any given community is really a function of how deep do you pump from or how long do you pump it. If you've got gravity-fed water, you've got very inexpensive water supply. Every community has ups and downs for wastewater collection and treatment. There are no flat communities and there's no perfectly downhill communities as far as I can tell. So on average, I would say that the average around the world would tend to look a lot like the averages in the United States. Now, specifically, it really matters, as you said earlier, Marianne, where you live. That's the embedded energy attached to the water. What water use happens at the end use, the energy attached to the water that's used, will vary all over the world. And that's the big variable, but that's not the point you were trying to make earlier today, that fundamentally it's the embedded energy in the water that we want to first pay attention to in the plumbing side. And then the energy attached to the water in the individual facilities is a separable question.
Do you know if any work has been done in Europe to analyze the embedded energy value?
I am unaware. I'm going there next week for a conference on water issues in Zaragoza, and I hope to find some people who may have begun to think about that.
Okay.
Yeah, Bill Erickson again. I was interested in some semantics here, and that is the use of the word energy. And has your organization broken that down into electricity, fuel, gas, and where the electricity or liquid fuel, because we're having in the plumbing industry, we're having a hard time using different sources of water. There's either fresh water, potable water, or none. But the energy / electricity / fuel gas, as far as a trade goes, is a little more complicated.
Right. Well, the slide that I didn't talk about much because you couldn't have read the individual bars anyway, is in the presentation, and that comes from EPRI. EPRI has done, the Electric Power Research Institute has done that work. And so that bar chart actually shows the contribution from the various energy sources. And, you know, again, it's very specific to the region. It depends on where the energy, how the energy is being derived, and as to what the offset value is likely to be.
And in the future, is it going to be referred to as energy rather than electricity? And do you see anything as far as water being referred to as gray water, green? Well,
the Energy Commission work in California basically differentiated between electricity versus natural gas, which are the two basic energy sources in California. So yes, you have to make that differentiation because it is going to be different. And so as a result, I think that as we take a look at this issue and go forward, we need to separate out those numbers and figure out what those values are, because that's going to be very important if we're going to go down the road of carbon footprint calculation and making sure that those energy trade-offs are correctly considered. Let me give you an example, and this is a conversation I had with Walmart. They were saying with a fair amount of pride that they were converting all of their facilities to evaporative air conditioning because they felt it was such a huge energy savings reduction, and reduction in their energy use. And I said, well, it depends on how much embedded energy is going to be in your water, because if you're making that trade-off in an arid area where the water is pumped large distances and none of it's gravity fed, as Gary says, you're possibly not making a positive energy calculation there. And they were very surprised. I said, well, how can we figure out how to do that calculation? And so that's one of the pieces that we may actually be working with them on together is coming up with a method for making that trade-off calculation. So we're providing information to those who are building new buildings as well as renovating old ones so that they're making smart choices, that they're not just thinking energy efficiency and not holistically about, total carbon footprint. So some of those tools are still yet to be built.
First, Marianne, great. On this whole energy thing too, I think one of the interesting things talking about kilowatt hours is don't forget that we need to also look at half the, about 80% of our electricity is developed with conventional steam electric power plants, and it takes about 3 BTUs per BTU you get out in the form of kWh out of that thing too. Right. And so when you put this into the total quad, I think we use 100. We're a 100 quad nation, I think, on total energy use. When you start getting to look at that, it gets to be a lot higher too. It's amazing. Thank you so much for your comments.
Good, thank you.
I think we're just on schedule, so I want to thank Marianne again for a great
Thank you.
We did.